Hello everyone, welcome to the fourth video of operating system series. Today we will be learning about the services and system calls of operating system. Operating systems are the backbone of computer system, providing essential services to users and ensuring the efficient operations of system itself. We will explore the various services provided by operating system, focusing on program execution, input output operations, error detection, etc. Program execution. The primary purpose of computer system is to enable users to execute programs. Operating system provides an environment where users can conveniently run programs. Program execution involves several critical tasks handled by operating system. Memory management. The operating system allocates and deallocates memory to the programs. It ensures that each program has sufficient memory for execution and optimizing the utilization of resources. CPU scheduling. In multi-programming environment where multiple programs run simultaneously, the operating system schedules CPU time. It determines the order and duration the program execution, ensuring fair and efficient utilization of CPU's processing speed. Then comes input output operations. Every program requires input and produces output. Operating system provides input output services to facilitate seamless program execution. Input operation. Users interact with the program by providing input through devices like keyboards, mice, or sensors. The operating system handles the communication between input devices and the program, making it convenient for users to supply data. And then output operations. Programs generate output that need to be displayed, printed, or saved. The operating system provides output devices such as screens, printers, storage devices, allowing the programs to send their data to appropriate destination. Then comes file system manipulation. Programs often need to read input from existing files or write output to existing files. The operating system provides file system manipulation services like file creation and deletion, file opening and closing, read, write, and repositioning, etc. Then comes communications. Programs often need to communicate with each other to exchange information during execution. Communication can occur during processes running on the same computer or on different computer. Operating system facilitates communication in two ways, which is shared memory and message passing. Shared memory processes can communicate by sharing a common memory space. The operating system manages access to shared memory, ensuring data consistency and synchronization between processes. Message passing. Processes can exchange messages through various communication mechanisms provided by OS. These mechanisms allow processes to send and receive messages, enabling efficient interprocess communication. Then comes error detection. To ensure the stability and reliability of the system, operating system constantly monitors for errors. An error in one part of the system can lead to malfunctioning of the entire system. Operating system detects errors and takes appropriate action to prevent them from propagating and causing system-wide failures. This relieves users from the worry of errors impacting systems functionality. These were the user convenience services. Now we will be looking at what it provides to the system itself. System operating services are like resource allocation, accounting, and protection. Resource allocation. When multiple users are logged onto the system or multiple jobs are running at the same time, resources must be allocated to each one of them. Many different types of resources are managed by the operating system. Accounting. The operating system keeps track of which user uses how many and which kind of computer resources. This record keeping may be used for accounting or accumulating usage of statistics. And protection. When several disjoint processes execute concurrently, it should not be possible for one process to interfere with another or with operating system itself. Protection involves ensuring that access to system resources is controlled. Security of the system from outsider is most important. Such security starts with each user to authenticate him with the system, which usually means the password to be allowed to access the operating system, etc. Now let's start with system calls. So system calls serve a crucial interface between user level processes and underlying operating system. They enable user process to request services and perform actions to otherwise restricted to operating system. So let's go to the next slide, which is understanding what it is. So the purpose of system calls is it acts as a gateway for the user processes to access system services and resources offered by OS. They allow user level processes to request actions that require privileged operations such as managing memory, file operations, device control, process control, communication by providing controlled and secure interface. System calls ensure that user processes can interact with operating system in a controlled and protected manner. So then there are a few types of system calls. OS provides system calls for various needs like process control, creating a process, requesting the operating system to create a new process, terminate a process, instructs OS to terminate a process, get process attributes, set process attributes. And then comes file management. We can create a file, delete a file, open a file, read, write, repositioning, and get or set file attributes. These come under file management. Then comes device management. We can request device, which is request for the access of a specific device. We can release devices, release previously requested devices. Read, write, repositioning, get, set device attributes, and attach and detach devices. Then comes information maintenance. We can set or get the date and time. We can set or get the system data. We can get or set the process, files, and device attributes. Then comes communication. We can create or delete a communication connection. We can send or receive messages. We can transfer status information. We can attach, detach remote devices. Then how to execute system calls. When a user level process needs to invoke a system call, it follows a specific procedure. Okay, the process prepares the required parameters and places them in a predefined location such as registers. Then the process triggers an interrupt, executes a specific instruction, transitioning to the from user mode to the kernel mode, indicating the start of system call. So basically users are always in user mode, but when a system call is called, then it transits to uh, transits from user mode to the system mode. And then these are few examples of system calls for process management. We can fork a process, we can execute a process, we can wait, we can exit. And similarly for file management, we can open, read, write, close. Device, we can do IOCTL, read, write. And for information maintenance, we can get the time, stat, get PID. And for communication, we can get a socket, we can send or receive between processes. So now, what are the benefits of system call? It's standardized interface. So system call provides a consistent portable interface, okay, for a process OS interaction. And it also helps in resource management, so that we can ensure proper allocation and delocation of resources. We can also have access control. So this is very important. Access control is very important, or else anyone can do anything with the system resources. So system call enforces a security policy which provides to prevent unauthorized access of system resources. Then there comes synchronization and communication. They facilitate in IPC, interprocess communication, and synchronization between collaborative tasks. Two processes can collaborate with each other through interprocess communication. So this was all about OS services and system call. Hope you understood. Thank you.